We are live. Check, check. There it goes. All right. Well, welcome to the stream, everyone. I'm Noctophonics, and today we are diving into some more of JavaScript and Phaser. Last time we went through one of the game development projects. They had us work through a treasure hunting game where in the browser you would have a number of plots that you could choose from to dig in and see if you could find some gold. It was actually pretty fun. That's going to be posted on YouTube. I'm going to do some editing to it before I post it because the stream was a little bit choppy that time, so I'm going to stitch it all together and put it up on there. It's going to be under the same channel name as is here, Noctophonics, if you want to go check that out. So today we're going to jump into the Iterators section in the JavaScript course on CodeCademy. This has to do with higher order functions, basically putting a function inside of a function as an argument. So let's get started with that. All right, JavaScript iterators. We've learned about functions and how they can accept information in the form of arguments, but now we're going one level further. Functions accepting functions as arguments, otherwise known as higher order functions. We'll explore more of the intricacies of pattern. We'll also see how this translates to using callback functions and the use of iterators, array methods, to loop through an array and perform various actions. As you continue to program, you'll see this pattern pop in many projects, especially in Phaser syntax. You'll also get a better sense of what this new vocabulary means. You got this. Like with the previous material, you'll understand it after more practice and experience. All right, let's start the lesson. Introduction. We're often unaware of the number of assumptions we make communicating in our native languages. If we told you to count to 3, we would expect you to say the numbers 1, 2, and 3. We assumed you would know to start with 1 and end with 3. With programming, we need to be more explicit with our directions to the computer. Here's how we might tell the computer to count to 3. 4, and then we'd set up a for loop. Let I equal 1. Whenever I is less or than or equal to 3, increase the number of I, and log to the console whatever the I is equal to. When we speak to other humans, we share a vocabulary that provides quick ways to communicate complicated concepts. When we say the word bake, it calls to mind a familiar subroutine: preheating an oven, putting something into an oven for a set amount of time, and finally removing it. This allows us to abstract away a lot of the details and communicate key concepts more concisely. Instead of listing all those details, we can say, we baked a cake, and still impart all that meaning to you. In this lesson, we'll learn how to use abstraction in programming by writing functions. In addition to allowing us to reuse our code, functions help to make clear, readable programs. If you encounter a count to 3 function in a program, you might be able to quickly guess what the function does without having to stop and read the function's body. We're also going to learn about a way to add another level of abstraction to our programming: higher order functions. Higher order functions are functions that accept other functions as arguments and or return functions as output. This enables us to build abstractions on other abstractions, just like we hosted a birthday party is an abstraction that may build on the abstraction we made a cake. Using abstraction allows us to write more modular code, which is easier to read and debug. Okay, cool. So we are stacking the layers of a cake. All right, functions as data. JavaScript functions behave like any other data type in the language. We can assign functions to variables, and we can reassign them to new variables. Below we have an annoyingly long function name that hurts the readability of any code in which it is used. Note if the below function syntax feels familiar or feels unfamiliar, revisit the arrow function exercise to refresh your knowledge. Okay, so we got an arrow function set up here, empty parentheses with that fat arrow, equal sign, and greater than symbol, and then our function body. But this name is pretty long. Announce that I am doing important work. I am doing important work. Doing very important work. Let's pretend this function does important work and needs to be called repeatedly. To rename this function without sacrificing the source code, we can reassign the function to a variable with a suitably short name. So if you have a function like this and you don't necessarily want to change the function name because it's already being used further down in the code, you can simply add a variable and have it equal to the function name. So every time you call the variable as a function, then it will reference that. This function call barely takes up any space. Yeah, busy is a variable that holds a reference to our original function. If we could look up the address in memory of busy and the address in memory of announce that I'm doing important work, they would point at the same place. Our new busy function can be invoked with parentheses as if that was the name we originally gave our function. Notice how we assign announce that I am doing important work without parentheses as the value to the busy variable. We want to assign the value of the function itself, not the value it returns when invoked. In JavaScript, functions are first-class objects. This means that, like other objects you've encountered, JavaScript functions can have properties and methods. Since functions are a type of object, they have properties such as .length and .name, and methods such as .toString. You can see more about the methods and properties of functions in the documentation. Functions are special because we can invoke them, but we can still treat them like any other type of data. Let's get some practice doing that. All right, so we've defined a function with a very long name. Check that 2 plus 2 equals 4 a million times. This function takes a long time to execute. It checks whether 2 plus 2 equals 4, but it does it a million times just to be really sure. Using constant, we declare a shorter name variable is 2 plus 2. That will be easier to work with. So assign the long one to the 2 plus 2. Okay, so you got the function set up here with a constant declaration, arrow function, and then we have a for loop. I is equal to 1. Whenever I is less than a million, I increases by 1. And then if 2 plus 2 does not equal 4, console log something went very wrong with a space and colon. I'm guessing we'll have some fun with this in a second, but for now we're just reassigning the constant function name to a variable of is 2 plus 2, and that will make our code a little more readable. So 2 plus 2, and then we're gonna just copy this, check that 2 plus 2 equals 4 a million times down here. And when you're assigning a function to a variable, you don't have to put the parentheses at the end of the functions because you're not calling it. If you called it, then whenever you reference this variable, it would activate the function and run it again. So you then have like 2 million times this for loop would run if you ran the variable and ran the function. But okay, so we'll do that is 2 plus 2, reassign that, and then invoke the function. So just is 2 plus 2. And when you do call it, even though you reassign it as a variable, you do need to put those parentheses after it. If we forgot the original name of our function, is there a way we could figure it out? Use is 2 plus 2 to console log the name property of the function we assigned to 2 plus 2. Interesting. So console log, and then this is the name property of is 2 plus 2. Dot name. I believe that should work. Yeah, cool. So yeah, if you see a variable that's, if you see a variable that's equal to a function, you can just see what the function name is. But if you don't know, for some reason, what the function name is, because you see this call down in the code and you don't know where the variable is, and you can't find the function either, you can do a .name method on the is 2 plus 2, and that will pop up with what you assigned that variable to. All right, functions as parameters. As you know, a parameter is a placeholder for the data that gets passed into a function. Since functions can behave like any other data type in JavaScript, it might not surprise you to learn that functions can accept other functions as parameters. A higher order function is a function that either accepts functions as parameters, returns a function, or both. We call functions that get passed in as parameters callback functions. Callback functions get invoked during the execution of the higher order function. When we invoke a higher order function, and pass another function in as an argument, we don't invoke the argument function. Invoking it would evaluate to passing in the return value of that function call. With callback functions, we pass in the function itself by typing the function name without the parentheses. So here they have listed a higher order function with one parameter, setting a function within that higher order function, and then returning, I just invoked the parameter.name function as a callback function. So within the code block of the one function, you are calling another. So this is a callback to something else with a parameter. And then let's see, so constant, another function, they set up another one. I'm being invoked by the higher order function. So this is the one that they're passing through the parameter down at the bottom here. So they're saying they're calling the higher order function and then passing in as an argument this function. So then when this parameter is passed through the code block, that parameter is now this function, and that function will run. As I said, you don't need the parentheses at the end of this when you're calling it or using the callback function, because you have them here, right? So you're calling it back, but inside of the higher order function call, you don't need the parentheses. If you did, then it would run it. It would either run it twice or just throw an error, because you would have technically two sets of the function running in the parentheses. All right, we wrote a higher order function. And that's explaining everything that we just saw there. Lastly, we invoke higher order function passing another function as its argument, thus fulfilling its dreams of being called by the higher order function. Okay, so for this one, higher order function, that's interesting. So they have these parentheses outside of the empty parentheses for the parameters. I wonder why that is. For let I equal 0, I is less than or equal to 10, I plus plus, console log I. In this example, we invoked higher order function with an anonymous function, a function without a name. That counts to 10. Anonymous functions can be arguments too. Let's get some practice with any practice. Oh, that's interesting. So they're just giving us a little appetizer of what anonymous functions do, what they look like. So yeah, you encase the function, the anonymous function, within the higher order function, and that's why these parentheses are outside of the code block and outside of the function expression. That's interesting. But so literally it's just saying this is a function, we haven't named it yet, but it's being contained within higher order function. That's very interesting. Okay. I don't know how you would say that, like how you would pass through anonymous functions as arguments, unless you write out the whole thing, the whole block of code as the parameter. I'm not sure, they didn't explain that, but I'm sure we'll learn that here in a few. Here we have a function, add2. Okay, so in the console, let's see, add2, parameter of number, return number plus 2. Okay, below that we've created what will be a higher order function, check consistent output. The purpose of the higher order function will be to check the work of add2. So let's get started. Okay, to begin, inside the body of check consistent output, declare two variables, check A and check B. Check A stores the value of the sum val plus 2, and B stores the invocation of function callback with val as the argument. Okay, so let's do that first one. They've set up the higher order function here with two parameters. Inside, we're declaring two variables. Check A equals val plus 2, stores the sum. So it's just going to be that second parameter, right? That second parameter plus 2. Okay, just that. And then constant check B. This one is, it stores the invocation of the function callback with val as the argument. Okay. See there? All right. So with that, yeah, we haven't put in something for val, but once there's an argument passed through val, then val will, it will add to val with this variable check A, and then with the check B variable, that will take val and run it through this function, which I think is doing the same as check A, because it's just the number plus 2. Okay, next, below the variables, write a conditional statement that checks if the value of check A is equal to the value of check B. If true, return the result of the callback function. If false, return the result of the string inconsistent results. Nice. So this is like almost like an error check. So it's saying that, yeah, so since the higher order, or not the higher order, the function at the top here of the editor is doing the same operation as check A is, then we're checking to see if these two values for the call function with val, which passes through as the num parameter and is added to 2, is equal to itself added to 2. So let's do check A is equal to 3 equal signs check B, and then if so, console log, or no, this is return, right? Return the result of the callback function. So this is going to return the result of function.val, or no? Return the result of the callback function. Because these variables are not being used as function calls yet. So what would this check A? I guess this would just be check B, right? You just return the value of check B. And then else, if it doesn't equal, if they are not equivalent, then you console log the inconsistent results, yeah. Okay. Yeah, okay. Finally, using console log the invocation of consistent output with 2 arguments, the add to function and any number. So down here in the console log, check consistent output. And then for the parameters, we're doing the add to function for function. Yeah, okay, so add to, and then I don't think it needs the parentheses there. We'll see in a second. Add to, and then the value, any number, so 23. Let's try that. Okay, so maybe you do need the parentheses here. No. Let's see, check consistent output within the console log of 20. Console log parentheses. Oh, I see. I need another parenthesis there. There we go. And now these parentheses can be deleted. That's what was missing. I was missing the final parenthesis of the callback function. Okay, so what happens here? So add to is an argument that's passed through function, and 23 is an argument that's passed through the parameter of val. So wherever you see function and val, those are equal to add to and 23, respectively. And so in this function, val plus 2 will be 25, and then function, which is add to, of 23. So then this 23 is passed in through number, because this is the function that we're using as the function here. So add to with the parameter, or the argument that's passed through as 23, runs through the code block and then becomes 25. And then this check happens. It says, is check A, which was 25, equal to check B, which was 25? It was, so then you return check B. Now, if you try it again, but this time you change the number of check A, so say it's equal to val plus 3, and then run it again, it'll show inconsistent results. And it will also give you this undefined at the bottom, because it's like not able to give you a value for the console log, the other side of the console log, right? So it's trying to do the add to function, but it can't, because it's just console logging inconsistent results and then ending. So yeah, so that seems to be working just fine as 25. And then you can add any number down here, change that up, and it will always add to 2 as long as you've got the check A set correctly. Okay, great job. By thinking about functions as data and learning about higher order functions, you've taken important steps in learning to write clean, modular code that takes advantage of JavaScript's flexibility. Let's review what we've learned in this lesson. So abstraction allows us to write complicated code in a way that's easy to reuse, debug, and understand for human readers. We can work with functions the same way we work with any other type of data, including reassigning them to new variables. JavaScript functions are first-class objects, so they have properties and methods like any other object. Functions can be passed into other functions as parameters. A higher order function is a function that either accepts a function as parameters, returns a function, or both. Feel free to play around with the code in the workspace. What happens if we change the value of 2 to check A? Oh yeah, so we actually did that already in the previous one. This is just giving us all of the code that we wrote in the previous exercise. Which variable holds the callback function? So the variable that holds the callback is check B. And then what happens if you invoke the function's argument? Which function though? Which function's argument? If you invoke this function's argument, as I'm not sure what they're exactly asking in that one, what happens if you invoke the function's argument, which function they're talking about, or what exactly they're saying. So saying like you take what is passed through here and you invoke it. So like if you did an add to val as well, something like that. So this would become add to. I mean, it'll just come back with inconsistent results, right? Add to. Yeah, it'll just come back with undefined and inconsistent results. Okay. In the following lesson, you'll learn how higher order functions are used in some of the most important and widely used JavaScript methods, iterators. Okay. So those were functions within function. Introduction to iterators. Imagine you had a grocery list and you wanted to know what each item on the list was. You'd have to scan through each row and check for the item. This common task is similar to what we have to do when we want to iterate over or loop through an array. One tool at our disposal is the for loop. However, we also have access to built-in array methods, which make looping easier. The built-in JavaScript array methods that help us iterate are called iteration methods, at times referred to as iterators. Iterators are the methods called on arrays to manipulate elements and return values. In this lesson, you'll learn the syntax for these methods, their return values, how to use the documentation to understand them, and how to choose the right iterator method for a given task. Okay, inspect the code and notice the different methods being called on the arrays: the for each, .map, and .filter. Run the code to see the output. All right, what do we got going on here? I'll go ahead and run the code on the side there. Constant artists: Picasso, Kahlo, Matisse, Utamaro. Artist.forEach. So this is using the for each method to iterate through an array. So I'm guessing it's like for each value, each index, it takes the artist and sends this line of code, this block of code, into the array. So console log this artist. Okay, so for each is acting as an index reference, so the artist would then be whatever is at that index, and then you'd console log that artist is one of my favorite artists. So each time it runs through this, it will run through Picasso, Kahlo, Matisse, and Utamaro, and then say is one of my favorite artists appended to the name of the artist. Then constant numbers, 1, 2, 3, 4, 5, and constant square numbers, numbers.map number return number times number. So the map iterator is taking the index of the number, and then it's returning the number times itself. So you're creating an array of square numbers. Yeah, that's interesting. So the map creates like a new array based on the array that you had, but you don't have to put in the brackets. You just leave it as is, and then it'll create the brackets in the console log. So then it console logs the square numbers, constant.things equals this array, desk, chair, 5, backpack, 3.14, 100. So then there's a filter stored in this variable. So this filter iterator is looking at each index of the things and then returning type of only if the thing equals a number. So that type of keyword we saw a long time ago, that was like almost I think that was in the first few lessons, where we can take any variable and ask what type of thing it is. So it'll return with a string or with a number. But this is saying if the keyword type of, if the thing is equal to a number, then return it. And if not, then it will eliminate the desk, chair, and backpack, and then we only get the numbers that were stored in that array. All right, and then console log only numbers. Okay, pretty self-explanatory. The for each method. The first iteration method we're going to learn is .forEach. Aptly named, for each will execute the same code for each element of an array. Constant groceries equals brown sugar, salt, cranberries, and walnuts. Groceries.forEach function, grocery item, and you console log it. So this is the iterator, and the callback function is within it. So the code above will log a nicely formatted list of the groceries to the console. Let's explore the syntax of invoking for each. Groceries.forEach calls the for each method on the groceries array. Yeah, so this is the array, that variable, calls that method on it. For each takes an argument of a callback function, everything highlighted in purple there. Remember, a callback function is a function passed as an argument into another function. And for each loops through the array and executes the callback function for each element. During each execution, the current element is passed as an argument to the callback function. So this runs multiple times, just like a loop, until the array is all of the items in the array have run through that function body. The return value for each will always be undefined. Yeah, so if you try to return like what the value of the function is, it'll always be undefined because it's not referencing the array. It would have to reference the array first and then return those values. So basically you would need to put whatever variable you had at the beginning of this for it not to be undefined. Another way to pass a callback for each is to use arrow function syntax, make it a little bit more condensed. Groceries.forEach, grocery item, the arrow, console log grocery item. And that way you're not writing it twice or writing a function name. You're just writing what the function does. We can also define a function beforehand to be used as the callback function. Function print grocery element, console log element, groceries.forEach print grocery. Okay, so the above example uses a function declaration, but you can also use an expression or arrow function as well. All three code snippets do the same thing in each array method. We can use any of the three examples to supply a callback function as an argument to the iterator. It's good to be aware of the different ways to pass in callback functions as arguments in iterators because developers have different stylistic preferences. Nonetheless, due to the strong adoption of ES6, we will be using arrow function syntax in the later exercises. Okay, printing the for each for grocery as a callback function, yeah. So groceries is stored like we saw up here in this diagram. And so it will take that array, and then for each, it'll print grocery, which is a function that takes each element, which that parameter is now seeing the array indices and taking those elements, taking the elements of the array and putting it into here, which is console logging those. So that's a way where the functions can be within or called within a method. All right, so iterate over the fruits array to log I want to eat a plus the name of each fruit. For example, I want to eat a mango. You may use any form of callback you prefer. Okay. Constant fruits. Okay, so any form of callback. So this will just be for each method of fruits. So we want the fruits first, fruits dot for each. And then with this, you need parentheses, and then it's like this, right? Where you do equal sign, arrow function, code block, and then this will console log for each fruit, right? That's the parameter. Fruit console log fruit plus, and then I want to eat, or this needs to go at the end because you're saying I want to eat a, and then put in the fruit. Fruit. It's probably wrong, but let's see. Oh no, that worked. Okay, cool. Yeah. So simple as that. You put it as an arrow function there. You could also do it where it's a declaration. Like in 2 steps, you could say groceries and then do a function declaration like this, where you put in a new name, like say label fruit, and then it would act the same as you do the for each method. Because basically the for each method is looking inside of here and seeing that the syntax is appropriate for it, and then it will take those parameters and pass in arguments. So now we have I want to eat a mango, I want to eat a papaya, pineapple, and an apple, all nicely ordered from our array. If we add in another, thank you for the follow, if we add in another fruit in here, lemon, then it will also add to the console from that for each method. All right, welcome to the stream. Thank you for the follow. Thank you. Wish me luck. The .map method. Okay, so this one we saw a little bit earlier. The second iterator we're going to cover is .map. When .map is called on an array, it takes an argument of a callback function and returns a new array. Take a look at the example. So numbers has an array of 1 through 5. Big numbers, so we're mapping the number, and inside of this function we're multiplying by 10. And then this will return a new array of all of the numbers multiplied by 10. Okay. I think I just explained all of that here. We saw that working earlier. If we take a look at big numbers and big numbers, then yes, okay, so the output would then be 10 multiplied by each one, and it would output the array. Notice that the elements in numbers were not altered, and big numbers is a new array. Okay, so what do we have here? We have an array of animals, then have a log of a secret message to join something, and then we have a constant big numbers. Okay, let's see. So add your code under the animals array before the line console log secret message. Use .map to create a new array that contains the first character of each string in the animals array. Save the new array to a constant variable named secret message. Okay. So the syntax for this, we have to say animals.map. And then it was basically like the for each method too. So we'll give this secret message, right? That'll create a variable for it. And then the arrow function. Arrow function code block. And then this is for each animal, only use its first letter. So we need to have it be where it accesses the length of 1, right? Like if we put in a dot length, it would be, or the first index, right? So how do we, don't quite remember how to, I know it's where you put like brackets and then you put the first, like the first character, whatever that is. But I don't remember how to do it where it'd be like animals 1 of 1, and that would put out H, but I'm not sure. We're gonna have to experiment with that. But let me just double check my syntax here. So numbers.map. Okay, so this variable declaration actually needs to go on the outside of it. So this needs to be declared beforehand, which is a little bit different than what we did for the for each. But then after you declare it, then you can put in your mapping. And then this would be just like animal. I guess, yeah, we'll just put down animal. And return. So we want it to reference inside of the animals array. This will be animal. And then 1. I don't know if that will work. 1. But we shall see. Let's console log it. Or I guess we don't have to console log it. We just need to save it to that. So let's see. Yeah, it throws us an error. So syntax error. Cannot read property 1 of undefined. Okay. So return animal. Oh, I see. We don't have to reference the array again. It's already doing that. The .map method is giving us that. So we just need our property name and then 1. It did something. Oh, it's 0 index, so we need 0. Hey, cool. There we go. There we go. Hello, world. Nice. Nice. Yeah, okay, so that does work. So animal, you don't have to reference the array variable again because that's what the map method is doing. So it's saying that you're renaming whatever the variable is. You could even put, like, since it's only function scoped within the function, you could also name it the same, and then it would put out hello world. But yeah, so this is basically renaming that array, and then or each index of that array is being used. That's being passed through the function, and then it's showing which character it's putting out. Thank you for the follow. Welcome to the stream. Okay, next step, use .map to divide all the numbers in big numbers by 100. Hello world, how's it going? So save the return values to a variable declared with constant called small numbers. Create the small numbers array below. Okay. So we need a variable of small numbers. And going to divide all of them by 100. So this would be big numbers dot map. Inside of this, we rename that variable. So let's just say numbers, right, or num. Num, we do our arrow function, code block, and then this is just return big numbers. No, not big numbers, big numbers. Let's put a G there. There we go. Return num and divided by 100. Okay, let's try that. Okay, that worked, but I didn't console log it, so I just want to see our work. console log this result. There we go. 1, 2, 3, 4, 5. Sweet. All right. This is CodeCademy, although I have heard of Free Code Camp as well. The .filter method. Another useful iterator method is .filter. Like .map, .filter returns a new array. However, the .filter returns an array of elements after filtering out certain elements from the original array. The callback function for the .filter method should return true or false depending on the element that is passed to it. The elements that cause the callback function to return true are added to the new array. Take a look at the following example. Constant.words or constant words equals this array, short words, and then they're using the filter method and accessing the property length within each word and seeing if it's equal or if it's less than 6. If it's less than 6, then it will return it. If it's greater than, it will eliminate it from the console log. So words is an array. Yep. Okay. So we looked at that. Let's check the values of words and short words. Okay. So log words, that'll log the whole array. And then if you log the short words, it'll log only the ones that have 6 characters or fewer. Observe how many words or how words was not mutated. And short words is a new array. Okay. Cool, cool. Call the .filter method on random numbers to return values that are less than 250. Save them to a new array called small numbers declared with constant. Okay, so we're looking at this array up here. So small numbers less than 250. Okay, so constant variable. This is set up with the syntax that was like the .map method. So we do our variable declaration first. Numbers equals, and then we put in our random numbers .filter. And then we are renaming each element, giving a name to the parameter here. So just num, and then our arrow, and then code block. See that it is less than 250, so we return. We need num.length, or no, not .length. Num is less than or equal to. It just says less than, so less than 250. So let's try that. Okay, cool. And let's go ahead and console log that as well. Okay, cool. Yeah, it moved on to the next step, but, or no, it's just returning the console log of, interesting. It's not actually giving us a console log of the numbers less than 250. False, true, true, true. Oh, it's giving us the Boolean values of that. Save them to a new array. Declare with constant. Oh, that's interesting. So would you have this as like, that's really interesting. Let me check the syntax up here. So words.filter. Yep, we set all of that up properly. But for this, it's showing the Boolean values instead of the number values. Okay, we'll think about that for a second. We'll move on to the second step they've got for us and then go back to that. All right, now let's work on an array of strings. Invoke the .filter on the favorite words array to return elements that have more than 7 characters. Save the returned array to a constant variable named long favorite words. Yeah, see, this one says save it to a variable, whereas the first one said save it to a new array. I'm not sure what the syntax for that would be or where it would be. Unless you put it like here, right? Where you put like the brackets outside of everything, but that just feels strange. Yeah. I mean, it doesn't throw an error, but I think it kind of just ignores the brackets. So I don't know how to do that unless to say like like you set this equal to an empty array, and then you put the random numbers filter function into it. I'm not sure how to do that. But anyway, that's beyond the scope of their instructions here. So invoke the filter on the favorite words array and do long favorite words. So constant long favorite words. Long favorite words equals simply a variable, and then we take our favorite words dot filter, and we put in a name for the elements within that array. We'll just say word arrow function code block, and it's going to return the words that are less than 7. So word dot length is less than 7, or sorry, greater than 7. This is more than 7 characters. Okay, so that's true. Let's see what happens when we console log this. Oh wait, I see. Yeah, I see now. I'm console logging the operation instead of the result of the operation. So it's going to return the length, but then I need to console log the word property, right? So like return console log of word. Is that going to work? No. I guess it's just outside of this then. Console log the long favorite words, right? Yeah, that'll work. I was just wondering if it would work inside of the function. Okay, there it goes. Yeah. So then same thing for this. We console log it outside of the function. Console log small numbers. There we go. Yeah, so then it returns an array of those numbers, or anything above or below 250, and then this is any word that has more than 7 characters. Okay. Okay, what happens if we do... Yeah, so you don't need a function callback within a console log, but also that was just a variable, so that wouldn't have worked anyway. And so yeah, just console log those variables on the outside of the filter iterators. All right, the .findIndex method. We sometimes want to find the location of an element in an array. That's where the findIndex method comes in. Calling .findIndex on an array will return the index of the first element that evaluates the true in the callback function. Jumbled nums less than 10. Jumbled nums .findIndex return anything less than 10. Okay, so then jumbled nums is an array that contains elements that are numbers. This variable declares a new variable that stores the returned index number for invoking findIndex. And the callback function is an arrow function that has a single parameter. Each element in the jumbled nums array will be passed to this function, and num less than 10 is the condition that the elements are checked against. .findIndex will return the index of the first element, which evaluates the true for that condition. Let's take a look at what less than 10 evaluates to. So it outputs 3 because that's the first, so 5 there is the first number that qualifies for this condition, and so it will only output the first number that it sees that qualifies for that. That condition evaluates to true. So if we check what element has index of 3, then we get the output of 5, right? So the index of, or rather the find index, is showing us where it is. So this is in the third place, or the 4th place, right? Because it's 0 indexed, showing us what's in place 3, and then we can log what's in place 3 as 5. So this is like the reverse of, it's not quite the reverse of index of, it's actually like, it's more than that, because you can put in a conditional, a condition for that too. So it won't just tell you, like you put in an exact index number and then it will give you an element. You can actually put down a condition, and anything that qualifies for that condition will be sent back. Okay, so if there isn't a single element in the array that satisfies the condition, the find index will return -1. We saw this in our treasure hunter game. I remember there was a point where one of the elements in the array equaled -1, and it was giving us an error, and I wasn't sure what the -1 was about, but then I sort of figured that, okay, so that's if the array, or what's referencing the array, returns as undefined. Okay, so greater than 1000, jumbled nums.findIndex, return num greater than 1000. So there's nothing that's greater than 1000, so it will output -1. Okay, so I wonder if there's another method that will do the find index but return multiple values. They might get to that, but because there are two here that satisfy the condition, but it only returns the first one it sees and then it ends. So let's see, invoke, I guess maybe the way to do it would be to not have the return and just have, like, if number is less than 10, then return that number, right? So I guess that's just because the return is being used for the first number that it sees. Whereas you would put in like an extra layer of conditional to say if number is less than 10, code block return that number, right? All right, so invoke the .findIndex on animals array to find the index of the element that has the value elephant, and save the return value to a constant variable named foundAnimal. All right, so constant foundAnimal. Invoke this on animals, so animals.findIndex. Find index, we need to find the index of the element that has the value elephant. Okay. So this is the same setup as the map and the filters. We need to put in a name for the elements that we have. So just put in animal, arrow function, code block, oh, not brackets. We need the braces. Put in those curly braces and had one too many equal sign there. Okay. So return if animal is equal to element, or elephant. Yes, elements and elephants. Elephant. This has to be within a string. Okay. Sweet. Okay, so let's see if we can find the index of the first animal that starts with the letter S. Okay, so S. This would be return the index of the first element that starts with S, assign the return value to a constant name that starts with S. So for our next variable, starts with S. For this one, animals, same setup here, find index. And just put animal. Since these parameters are just, they only have function scope. They're not global variables. You can name them whatever you'd like. Animal, and you can repeat them if you like. So equals, then code block, return, return, there we go, animal. Starts with S. So animal with it's going to have an index of 0 equal to S. So we need animal bracket 0, and that will access the first letter in each string. This is equal to the string of S. No, not quite. Okay. animal dash 0. Return the index of the first element that starts with S. Okay, so this needs to be 2 layers. So if this return keyword is going to disappear, this is going to be set within a condition, code block, return animal. No, really? Animal dot 0 equals that. Did you call the find index method on animals and assign it to starts with S? Oh, it just wants that. Oh, it was just a spelling error there. I wonder if the other way was correct too. If we go back and see, but I think this is the way that you want to do it, where you set a condition and then return each animal that starts with S. That way you have, if there's multiple animals, say the seal and the salamander, when you console log it, it will have both the seal and the salamander, versus if you just say return, like what we had at the start, return animal 0 equals S, then it will only show you the first one it comes across and then stop the loop. That'll end the loop. But this way the loop won't end until it passes through all of the array elements. So this way now, if we console log both these things, so just to show, console log will do the found animal first, and then console log the starts with S. Starts with S. Oh, once again, starts, there we go. Starts with S. 7 and 3, wonderful. So there's 3 here. Or wait a second, it does that regardless, okay. So it ends the loop regardless. So it shows that 3 is the place where the first animal that starts with S is, and 7 is the elephant's place. I don't know how you would do it where you would want to show, like you would want to loop this, right? So you return the animal and then you go back and you loop this again. Return, or maybe you, I don't know. You might just need another method to do that. The reduce method. Another widely used iteration method is .reduce. The .reduce method returns a single value after iterating through the elements of an array, thereby reducing the array. Take a look at the example below. Constant numbers, sum numbers, numbers.reduce, 2 parameters of accumulator and current value, return the accumulator plus the current value. So it's taking each element from numbers, and then how do we, okay, so summed nums, right, is this variable, which is then accessing this array and reducing it. So for each of these, it's going to take an accumulator and a current value. Let's see, so here are the values of accumulator and current value as we iterate through the numbers in the array. So first, the accumulator is 1 because it sees that in the first place. Then the current value is 2, return value of 3. Okay, so the accumulator ends up being the first indexed number. So 1 is in the first index slot there. That's the accumulator. The second is current value. It runs this function, but then moves on to the next number it hasn't reached yet, and then uses the previous sum and adds it together again. So it's looping a sum. So basically 1 plus 2, that result plus 4, that result plus 10. Output is 17. Okay. So let's go over the reduce from the example above. Numbers is an array that contains numbers. I think we looked at that. It's pretty self-explanatory. This is basically a long form way of like telling it to sum all the numbers. Like they said at the beginning, you know, if you tell someone to count to 3, we know what that means. We can say 1, 2, 3. You don't have to explain the first and that first. You say 1. then you say 2, then you say 3. Now count to 3, right? But with code, you do that. So you make it very explicit, and you say, okay, this is how you sum everything. So you take the sum of the first 2 numbers, and then you add the next one, and then you add the next one. But then after you set that up, set that logic up, then you can just call the sum to nums, and it will do that for you. All right, so the reduce method can also take an optional second parameter to set an initial value for accumulator. The first argument is the callback function. For instance, if you have numbers.reduce accumulator and current value, return the accumulator plus the current value. And then, okay, this is kind of interesting. It's very interesting. So all of this is the first parameter. This is the second argument for reduce. So this is going to be put in as the initial value for accumulator. If you don't put this, then it will act as it did before, but all of this is within one parameter separated by that comma, and then 100 is the second parameter. So I'm guessing, even though they don't show us the skeleton of what the reduce method actually is, yeah, see, all of this is contained within parentheses, so this is acting as a parameter that can also have a second one added to it, like so. So then when you output the sum nums, the output is 117 because the accumulator begins with 1, and then instead of iterating 3 times, since it didn't start with 1, it'll iterate 4 times and end up with 117. Okay, so let's practice calling .reduce and using console log to check the values as reduce iterates through the array. In main.js, there is an array of numbers, new numbers. Okay. To start, declare a new variable named newSum using the constant keyword. Assign newSum to the value of calling reduce on new numbers. You don't need to provide any arguments to .reduce yet. Okay, so we need to have a new variable, newSum, set that equal to the effect of calling reduce on the new numbers. New numbers dot reduce. This then to provide any arguments yet. Okay, so it just wants us to see the type error. Undefined is not a function, yeah. Because that's showing that the method reduce needs arguments, right? It needs to have something to work with, or else it's just going to run as undefined. All right, so let's provide reduce with an argument of a callback function. The callback function has 2 parameters. The first parameter is accumulator, and the second parameter is current value. Use either a function expression or an arrow function. Okay, so provide reduce with an argument. Okay, so this is the same as we saw in the example, accumulator. And these are the parameters within the parameter, right? Because there are 2 parameters here that run in the function code, but then that whole block is then set as 1 parameter, and then you can add another one at the end. So accumulator current value. So this one actually needs to be set within another function here. So parentheses within these guys. Yeah, parentheses around these guys, and then arrow function, right? Arrow function of this. Oops, there we go. And then we have our code block. We do need to remember to put a parenthesis on the outside of this. If I can get my keyboard correctly. There we go. Okay. Within the code block, we're not doing anything for that yet. We're just showing this. There we go. Okay, to check the value being used, we iterate through the array, adding 3 statements to the function body of the callback. So we'll do console log the value of the accumulator and accumulator. Okay. So we'll copy these over. This is console logging just words and then the accumulator variable. The second line is going to console log the current value. Console log the current value. And then a return statement that adds accumulator to that. So return accumulator. So this will give us a tally as it goes through of what's happening behind the scenes for the whole loop. So return that. All right, sweet. Yeah, so return the first. So yeah, this is the first iteration. It shows 1 is being added to 3. And then 4 is being added to 5 because 4 would be the sum of 1 and 3. After 4 is added to 5, that sum is 9. And then that's being added to the last element within the array, which is 7. Okay, so log the value of new sum to the console to see the return value of calling reduce on new numbers. So down here, just log, console log that variable that we created, new sum. 16, woohoo, yeah. So that returns this value here. Before, when we just ran it, all that was being logged was what was in the function. This is just a return value that's kind of floating, right? Just imagine it kind of floating out in the global scope that console log can access. If it's not returned, then it won't be able to see it. Okay, so while we have this code set up, let's also check what happens if you add a second argument to .reduce. So this will be the initial value for the accumulator, and we are setting it to 10. So down here, after the curly brace, but before that final parenthesis, you add in 10. This will start as our initial value, and it will show you at the beginning that we start with 10, we add 1 to it, it becomes 11, we add 3, it becomes 14, we add 5, it becomes 19, we add 7, and finally you get to the value of 26. Also, you could do like a string of this that says total, right? Total is this, and then just add the accumulator value like that. Total. Oh, whoa. Total. Yeah. So it returned it for multiple, all of the loops. I guess that would have to be. That's interesting. That's very interesting. How would you add a string to the end of that one? 100 and 1,357. Total is 101. Total is 103. That's really weird. Because now it's adding it back into the function itself and console logging that, even though... Yeah, so it's doing like a feedback loop thing. That's very interesting. Can it not work with... Let's see if the interpolation works instead of this. So, Oh, in order to make this work, I think you would need to store it as a new variable. So you would then say like sum equals the accumulator plus current value, and then you would return total is sum. So instead of this, what I'm going to do is change this onto the upper line, make some room here. So we just are doing that calculation, but it's within the function. Then we're going to assign it to a variable. So constant sum equals this, return sum, and then add a string of total. And then that way I think we should end our feedback loop there with that. So let's try this. No, it still does that. That's interesting. And it still feeds it back into itself. That's very interesting. Okay. Total. So again, I want to see if the interpolation works instead of the concatenation. So let's try backticks and do total. Total is this, and then we do our $ and curly braces. Oh, and then we do another backtick to create our template literal. It still does it, huh? That's very strange. All right, let's go back to what we had, which was just this. That works just fine. You'd think that if there was a feedback loop, then it would be showing the numbers being added as well. But it's only when you start adding a string to this value that then it does that. It feeds it back into the accumulator. I don't know if that's because we were trying to reassign like a variable to this, and then that changes the accumulator values. Curious. Not sure. Iterator documentation. There are many additional built-in array methods, a complete list of which is on the MDN's array iteration methods page. The documentation for each method contains several sections: a definition, a block with the correct syntax, a list of parameters, the return value, an extended description, examples of the method's use, and other additional information. All right, so below there are some errors in the code. Use the documentation for a given method to determine the error, or fill in a blank to make the code run correctly. All right, so we're going to do some research here. So first we start out with a words array. Unique, uncanny, peak, oxymoron, guys. Something is missing in the method call below. Okay, so words.sum. Return word.length less than 6. All right, so in the code editor, there is an array called words. We want to create a new array of interesting words. The first thing we want to do is check if there are words that are fewer than 6 characters. There's something missing in the words method. Fix this method so that the true is printed to the console, okay? So instead of true at the moment, it's just not defined because word is not defined. Yeah, because we need the parameter to not be empty. We need this to have a parameter of word, and then that will be true, okay? For more information, browse the documentation on sum. So this documentation page is extremely helpful. It's the Mozilla Developer Network documentation on JavaScript. This will have all of your arrays, all of your functions, anything you could possibly want to look at within JavaScript and learn about. So we might take a peek at that if we get stuck on some of these methods here. This is a new one they're throwing at us. It's .sum. As we can see from here, it's set up. The syntax is very similar to the other methods we were using. But what it's doing is it's saying whether or not there is a value equal to this condition, right? It doesn't tell you what it is like the find index did, but it's telling you if there is one. And if there is one, it will send you a Boolean of true. This also has like the syntax of the double parentheses after the code block. So it can take another. Can I take another? Or no, that's just because we're console logging it. Yeah. Okay, so never mind. But yeah, so sum is basically taking each index and saying, it doesn't meet this condition. If it does, we will return true. And just like any other loop that has a return keyword inside of it, once that return is met, then that will end the loop there. All right, so there's some method return true, which means there are some words in the array that are shorter than 6 characters. Use the filter method to save any words longer than 5 characters to a new variable called interesting words, declared with constant. Okay, so constant interesting words equals, this will be words dot filter. This will have a parameter of word and arrow syntax code block. And we want to do longer than 5, so this will return not length greater than 5. Let's try that. I don't know. Yeah, that works. We didn't console log it, but we saved the value of any element greater than 5 characters. So the last line there is this code. that's commented out at the moment. You can bring that back into the light. Complete the code between the parentheses to check if every element has more than 5 characters. Make sure to uncomment or delete the 2 forward slashes before the last line of the program before you run the code. Okay. So we need to fix this. So interesting words.every. Okay, so something is missing inside of the code block, right? And also, I don't think, if it's just a single parameter, you don't need parentheses. So let's get rid of those. Around the parameter, those 2 at the end can stay. So to check if every element has more than 5 characters. So this one I think we'll have to check the documentation for. I'm guessing that it will be sort of something like, so you return word.length greater than 5, and that will return a Boolean value of true. Yeah, so this works similarly to sum, where it returns a Boolean value, but this one is looking and saying if every element in your array every element qualifies this for this condition. Every element is greater than 5 in this case, 5 characters long. Then that will equal true. Sum is just if one of them does it, right? Just one of them within the array. If one of them meets this condition, then it will be true. But with the .every, it needs to be every single element in the array meeting the condition. Okay, cool. Choose the right iterator. Okay, so there are many iteration methods you can choose. In addition to learning the correct syntax for the use of iteration methods, it is also important to learn how to choose the correct method for different scenarios. The exercises below will give you the opportunity to do just that. You'll see errors pop up in the terminal as you work through the exercise, but by the end the errors will be gone. Sweet. Okay, so what do we have here? So we have an array of cities. Yeah, Orlando, Dubai, Edinburgh, Chennai, Arca, Denver, blah, 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 Esquisse here, Medellin, Yokohama. Okay, cool. Array of numbers. We have a method. Okay, and then the rest of it is just going to be what we refactor. Okay, cool. Replace the word method in the first method with a call. The method call, or with a method that will do something for each of the values in the array and return undefined. Return undefined. So city, console log, have you visited city? Replace the word in the first method call with a method that will do something for each of the values, to each of the values, and return undefined. Okay, I'm trying to think of what the name, because we're going to have to search in the documentation for this, but I'm trying to think of what the name for that would be like. Have you visited city? Cities dot. The for each method, right? Isn't that one always undefined? Didn't they tell us that before? For each. Yeah. Yeah. Okay. So it does console log it, right? Like the code inside of the for each method runs, and it doesn't run as undefined. It actually outputs what you set inside of the console log. But the for each method itself, like if you were to say .for each console log that, it's going to be undefined as a whole because it has to run through its function before it shows you anything. It's almost like when you console log a function with the parentheses, it'll just say like function, or when you console log a function declaration, it'll just say like function colon and then whatever you named it. But in this case, when you do that sort of a thing, it'll come back with undefined. All right, so in the second method call, replace the word method with a method that will return a new array with only those elements longer than 7 characters. Okay, so only elements longer than this. So we want filter, right? Filter's going to do that for us. Sweet. Okay, in the third method call, replace the word method with a method that accepts an array containing multiple values and returns a single value. An array containing multiple values and returns a single value. Oh, this is reduced, right? This is the sum. Yay, cool. So that one was taking... Oh, that's cool. That's really cool, actually. So it can do it with strings, too. We only saw it with numbers, but it can do it with strings. So it'll take the C, right? Because they set that as the second argument, the first accumulator value, and then it runs through its accumulator, which is that letter, right? That character in the string, plus the current value, which is going to be the current element, index of 0, which would be the first letter. So then it will end up all caps with a message starting with C of all of these, and it ends up to be, of course, CodeCademy. All right, so in the fourth method call, replace the word method with a method that will return a new array of numbers returned from the function. Where is that one? This one here. Return a new array of numbers returned from the function. So this is map, right? Map. Yeah. In the fifth method call, replace the word method with a method that will return a Boolean value. So number less than 0. So this could be some or every. Yeah, just set every, and it's going to be equal to false. Yeah. We don't console log that, but it would be equal to false if we did. We saw that in the previous exercise. So add in console log after this, and we shall see false. Okay, cool. All right, awesome job on clearing the iterators lesson. You have learned a number of useful methods in this lesson, as well as how to use the JavaScript documentation from the Mozilla Developer Network to discover and understand additional methods. For each is used to execute the same code on every element in an array, but does not change the array and returns undefined. So it doesn't mutate, right? It's non-destructive. It's just referencing and then running a code on each element. And then you can console log it. You can do whatever you want to with that code, that array, or whatever it outputs. But it doesn't actually mutate the original array that you were referencing. .map executes the same code on every element in an array and returns a new array with the updated elements. .filter checks every element in an array to see if it meets a certain criteria and returns a new array with the elements that return truthy for the criteria. Find index returns the index of the first element in an array that satisfies a condition of the callback function, and it returns -1 if none of the elements in the array satisfies the condition. .reduce iterates through an array and takes the values of the elements and returns a single value. A sum of that value, right? I mean, I guess you could do it where, yeah, that could be anything, right? We were just seeing it as a sum. You could do any operation with that. You could do divided by 10 for each of the numbers, right? So all iterator methods take a callback function, which can be a predefined function, a function expression, or an arrow function. You can visit the MDN to learn more about iterator methods and other parts. Okay. If you want to challenge yourself to find a callback function before you use it as in an iterator. Pretty sure we did that in one of the exercises. Chain 2 iteration methods on the same array. So that would be like the .2 iteration methods. So basically, like you do a for each, right? So .for each, inside of the for each parentheses, you would put in a .filter. So it would say for each of those, filter it out. But I guess that would be sort of redundant because filter could do its own work. I guess it would be more like map, right? So you change it first, and then you filter out the mapped array. Use the optional arguments in an iterator to include the index of the entire array, or the entire array. Okay, so this is talking about like the one we saw with reduce. Use reduce to take a multi-layer array and return a single layer array from scratch. Okay, cool. So just an array of numbers and then sum the numbers Cool. All right. Alrighty. Let's start the quiz, shall we? And it looks like we got a project after that. Which of the following iterator methods returns undefined? For each always does. They told us that. Select the option that correctly assigns the increment function to the variable increment holder. Correctly assigns the function to the holder. So increment equals salary. Revised salary is salary plus 5. Console log revised salary, return revised salary. Okay. So increment function to the variable increment holder. Yeah, it's just this, because you don't need... First of all, this is passing through an argument. This isn't even named correctly, so it has to be this one. What would be a good second choice would be if you had the parentheses here, as if it was doing a callback function. Or this is the callback function, but as if you were just declaring it, just calling it normally. But okay, cool. For the assignment, you do not need those parentheses. Which of the following methods returns an array with values that evaluate to truthy based on the condition in the method's block? So that's the filter method. Map is not quite the same. It creates an array based off of an operation that you do to each element. In the following JavaScript code snippet, the callback function is CB is a function that sums the value of two numbers. Fill in the blank so that when the function is passed into higher order function, HOF, it is then invoked that the value returned is 8. Okay. So it sums the two values. So CB, with these two parameters, it returns the two parameters added to each other. This higher order function let the value equal... So when it is invoked so that the value is returned is 8. Okay, return this function returned value, and then you call this higher order function with the argument of CB variable. And then so CB is going to be put into or passed through that parameter. So let the value of CB, which is then going to be function, be 3 and 5. But we don't have to put, yeah, function there, right? So this parameter function is going to turn into CB, right? CB is going to be passed through that. So wherever function is referenced within the code block, that will turn into CB as well. So function 3 and 5, that will go back into CB and return 8. So let's check the answer on that. Sweet. Sweet. All right, examine the code below. Which of the functions represents a higher order function? All right, so higher order function, get function to string. Let's see, so the first one is simply, that's a simple function, a first order function with 2 parameters. This is also a simple order function with 1 parameter. This one, however, let get function string is higher order because it's receiving an argument and then using a method on that argument, so that's going to be a function, right? So let the result equal multiply 2 values, 2 and 2, and then square the result. That's interesting. So you multiply 2 and 2 for value 1 and 2, so that would be 4. And then you square, and then you square 4, which result is just a variable, and then that's containing a value from a first order function. Then that variable is being put into another first order function, but that's just to throw you off because that's not actually putting another function inside of it. This is that one. This is the functionception. So whatever is passed through this will then be used as a function of the 2 string. So this is the get function string is the higher order function. It accepts a function as a parameter. Yes, indeed. Okay, so the code snippet includes a function assigned to the variable sum. Given the fact that JavaScript functions are first-class objects, fill in the blanks so that the property of sum, called alias, is assigned to the string value summation. Okay, let me see if I can order that in my brain. So constant of sum equals this parameter, these two parameters within this function. So x plus y. Sum equals, right, the variable, a property of sum is called alias. Called alias is assigned to the string value. A property of sum, so is assigned to the string value of summation. So that goes there. Wait. Alias is equal to? Not sure about this one. So we're assigning summation to alias, right? So we want the single equal sign here, yeah. Fill in the blank so that a property of sum, which is a variable, a property of sum called alias, is assigned to the string value of summation. That word property is kind of throwing me off because I know that's what you call the things inside of an object, like the key value pairs and properties. Given the fact that functions are first-class objects. So first-class objects means you can flip the grammar, right? You can flip the syntax around. So this is going to be comma. A property of sum called alias is assigned to the string value summation. I'm not sure what they're wanting actually. Do they want, what's going to return this? So sum is the variable here, right? X plus y. Alias is going to be equal to the string value of summation. Sum is equal to alias. At first I'm thinking that they want this to be like the arguments, right? So sum would be the x argument, alias would be the y argument, and then you sum those. But that's not what they're wanting. They're just wanting the alias to be assigned as summation, and then sum to have alias as its property. I don't really understand this question. So if we have sum is equal to alias, right? That's a truthy value. But then we're saying that alias is equal to summation, or assigning it summation. So then the sum would be equal to whatever alias is equal to. So then the string of sum variable would equal summation. I'm really not sure about this one. Let's check the answer. Okay, so this is incorrect. The notation used to show that alias is a property of sum. So it doesn't actually show us the answer. It just says that this is, the notation used to show that the alias is a property of sum. So is that just a comma then? I don't know. I'm gonna have to come back to that one. I'm not sure about that one. Use the .map method on the odd numbers array to return each number multiplied by 2 to the even numbers array. Okay, so odd numbers 1, 3, 5, and 7. Even numbers variable, we're mapping this. So we're doing odd numbers.map is number return number times 2, and then that will give us an array of even numbers from the odd numbers. Sweet. What is the value of found element after the code runs? So constant random numbers, this array, found element is using a find index on the numbers if the numbers are greater than 200. So it's going to be 4, yeah. So that's the fifth element. It's going to be 4. Yeah. Okay, cool. Fill in the blanks to make it added up log 100 to the console. Initializer of 90. So the 90 needs to go down in the bottom as the second parameter. So reduced, nums.reduce accumulator, we need a current value, return accumulator plus current value, and then the initializer will be stored in the bottom as the first value it uses as its accumulator. So then added together, it will be 90 plus the result of this, which is 10, which will be 100. Sweet. All right, so let's take that again. I'm very curious about the that one like property question. It's very unfamiliar. So this returns undefined. That does, let's just speed through this stuff. So increment, this was just the increment like so. Evaluates to truthy based on filter. Okay. The value equal, this was function 3 and 5. This one is the get function string. Okay, this one. The length. Oh, the property. Okay, it just dawned on me. So property, first class objects. First class objects have methods assigned to them, right? Or you can not methods, properties to them. You can pull properties of them, right? Like arrays. You can pull the property of a data value like length. Like you can say what is this element? How many characters does it have, right? That's the dot length property. That's what they call them. Which that is, we don't see it, but that is stored in like a database object that says, okay, these are all the properties of that first class object. So any first class object has properties. So that way we know to use the dot, just a period there. So sum dot alias. It's confusing because this would actually be blue. They're color coding. This would actually be blue instead of red. So I was reading it like a variable instead of a property, but it will become blue once we put that dot in. So sum dot alias equals summation. So then you're changing the property name, you're reassigning it summation. That makes way more sense. Okay, cool. All right, this one was odd numbers and mapping it to number plus or times 2. This one was 4. This one was reduce accumulator and current value. Accumulator goes here, current value goes at the top, and then initializer at the bottom. Sweet. Booyah. Continue learning. All right, on to the project of grammar checker. Alrighty. Grammar checker. In this project, you'll use what you know about iterating over arrays to gather information and improve the quality of a paragraph. If you get stuck during this project, you can get some help there. Okay? So getting started. So the story variable, this little guy, holds the paragraph we'll be editing. In order to edit the story, we turn it into an array on line 3 using the .split method. The .split method separates the story string by the space character space and stores each word as an element of an array. That's very useful. So it's kind of like join in the fact that it uses an input of a character. So you can put in, if you put in like a period or a comma, you could also log those into the array here. Or if you were making a list with join, you could put in a comma and then there would be a comma after each element. But for this case, we're putting each word into an array. And it's interesting that it doesn't like log the spaces, you know what I mean? So it's like it's looking at last, right, as a word. So this method must say that if the character is anything other than a space, then you log it as the first index. Of course, then you have to add a space after that because it's not storing the spaces, right? So if there is anything that's not a space, log it. If it is a space, skip it and then log the next one, right? That way you keep your words separate. But then to put it into the array, you want it to be separated a little bit so that it's not all jumbled. So you put a little space in there. Okay, to see the array we'll be working with throughout the lesson, log story words to the console. Okay, so let's log console log and story words. There we go. Okay, so this is the whole list of all of the words in an array. And yeah, as you can see, it added in like a space between each of them. Or, oh, I see. Okay, so the split is taking this as like its input, right? It's saying, look at this. This is what we don't want, right? So look at the characters in this variable. If the character is not what's in here, keep it. If it is, then get rid of it, right? So that way we don't have spaces after each of our elements. We do have the commas, which would be interesting if we put in a comma there, if it would, like, yeah, if we put in a comma, then it would add the spaces. Let's see if we do that. Let's do this. Yeah, interesting. Okay. So every time there is a comma, then it creates a new section. That's interesting. So that could be like another type of grammar checker to check for, run-on sentences or what have you. But, or you could even do periods, right? So periods. So for each sentence, then it separates the elements. That's interesting. But for now, we'll just do it as spaces, and that'll separate each word. But it logs it 81 more times. Oh, okay. So that is a very long array, and it's not showing everything, but that's fine. We know that is working properly. For better visual comparison of the original and edited stories, we want to view the edited story words array as a string. To change the story words array back to a readable string, we can invoke the join method on story words. Give the join method an argument of an empty space to separate each array element with a space in the string. Place the join method invocation as an argument of a console log statement to log the final story to the console. So story words, join, and then like the split method, we add in parentheses and a space. Sweet. So it says, last weekend I took literally the most beautiful bike ride of my life. The route was called the 9W to Nyack. I'm not going to read the whole thing, but there you go. That's how you put it into a string format, from taking a string, putting it into an array, and then taking the array and putting it back to a string. Basically, they just want to show the differences as we edit the grammar. So you could basically do what we had before, where we console logged story words by itself, and it comes up with the split, right? Okay, so now it's time to start editing the story by manipulating the story words array. We want to be able to see the changes, so be sure your console.log of the joined story is the last line of code in your editor. Okay, so that'll be the last line. First, above that uses the join method, create a variable named count that stores the number 0. I'm just going to use constants here. Constant count equals 0. Okay. Directly below count, use a for each method to iterate over story words array. As an argument of the for each method, create an empty function to be used as a callback function. While ES6 arrow syntax is recommended for the callback function, feel free to use any syntax you are comfortable with. Okay. Argument of the for each, create an empty function as the callback. So this is an anonymous function. Okay. Is this being stored as a variable, or they didn't say it was? It's just like using the method to iterate over the variable that's there. So story words dot for each. Okay. This would then have an empty function in it. So we're going to use the arrow function. So empty equal sign fat arrow, and then we do the brackets, right? I think that's all that we need for now. We're going to put something in there later. Okay. I really don't know how you would declare an anonymous function. They didn't go over that, but I think this is how you would do it for the arrow syntax. Okay, so for each word in the story words array, we want the count variable to increment by 1. Add a parameter named word to the callback function of the for each method to be used to store the current element when iterating over the story words array. Each time the story word iterates, increment count by 1. Story words, they didn't put an S on that, but okay. Story words. Increment count by 1. Okay, so word needs to go here. So this will be our parameter, right? Inside of this, the method to be used to store the current element when iterating over the story words array. Right. Parameter of that on the count variable to increment by 1. For each word, count is plus plus, right? That's it. I think that's it. Count plus plus. Oops, plus plus. Okay. And then this is just going to be console log count. But count is not. Wait a second, I missed something. Where was count? We want count variable to increment by 1. Yeah. So count's out there. So the count does have global scope, so that's going to be fine. Count will increment by 1 with the for each method. Assignment to a constant. Oh, yeah. Okay, so that does need to be let. Yeah. There we go. Okay, so that will be 181. Sweet. So that worked. I thought there would be more here, but no, it's just count plus plus, iterate that by 1. Yeah, code is so concise. It was like there's many words to explain that, but it's just count increments by 1. All right, filtering words. A word count of 181 is a bit long for this story. Let's filter out all the instances of the word literally to shorten the story and remove the unnecessary word. We will reassign the filtered story to the same story words variable by applying the filter method. Throughout the project, we will use this approach of reassigning the story words variable for each revision of the story. Below where you logged the count variable, reassign the story words variable to equal the invocation of the .filter method on the story words array. Give the .filter method a callback function with a parameter of word. Okay. So for this, let's give it some more space here. I think they say to reassign it. I don't know. To reassign it to a filtered version of it. Okay, so yeah, let's just do that. So yeah, story words dot, or not dot, this is story words equals. So reassigning the variable of it, but we are going to put it down again. So story words dot filter. The filter is then going to have a parameter of word. This is going to have the arrow function syntax, brackets or braces. We use this approach for that. Okay. Dot filter. I think they just wanted us to set that up. and then get rid of the word literally. So if, let's see, how would we do that? So if, basically we're looking at if the word equals literally, but if the index of the word, or filter if word, oh, I see. Yeah, since we have it in an array, right, as an array, that makes more sense. Okay, so story words is setting up an array of all of these words and is separating them into separate indices, right? So we can access each one individually, and that way whenever we do our methods, it will run through each one as its own element. So it's going to essentially run this code 181 times to see if each word is equal to literally. So this is returning, give the filter method a callback function with the parameter of word. I don't think we need to return. I think we just need oh yeah, we do want to return, but we want to return if it's not equal to literally, right? So return if word is not equal to literally. Not sure if that's the right syntax, but we'll know in a moment if that works. Yeah, sweet. So even from the start, so since our join console log is at the bottom, it goes through every word first, changes the count, and then eliminates the word literally. So it'll set up our array, and then it will find the words literally and remove them from the last console log. And let's also see what happens when we console log the count. I guess count would be, I wonder if you did story words, this variable assignment above story words for each, that the count would change. So we change this, the order of this. I don't know why it's not selecting that letter, but okay, there we go. Change the order of this. So we have our for each method underneath the filter method and then run the count. It's not going to be 181 anymore. It's going to be 178 because we got rid of the literally. That's cool. Okay, so below story words variable declaration, we'll notice the variable unnecessary word on line 4. All right, that's this one here. We want to filter out the value of that from the story. Oh, this is just showing what we did, but with different words. So they're gonna put in this variable instead of the string, right? Return word only if it is not equal to the unnecessary word, and check the story string in the console. Make sure it doesn't include the word literally, and the first instance of literally was previously in the first sentence. So this is a better way to do it because you can then change your unnecessary word. So let's put that down here for the string, right? So the same code, except we are changing our string to the variable that's storing the string. And then it's going to output the same. But what we can do then is change the unnecessary word to like redundant or something, or just say like there's the word for end at the end, right? So change to end, and then did that work? You're very close to the end. That did not work. If word is not equal to unnecessary word. Did we save? That's really strange. This should be, oh, because it has a period. It has a period. We need to add the period there. There we go. Yeah. So you can add in whatever you want in the unnecessary word, and it will remove it from that string. All right, let's see. What is the next step on here? And we'll go ahead and go back to literally. Literally as our unnecessary word. Replacing words. Now that we've removed the unnecessary words, let's take care of any misspelled words in the story. We can reassign story words to a new array of spell check words using the map method. Reassign story words to equal the invocation of the map method on the story words array and set word as a parameter. In the body, define a conditional statement to check if the word argument is equal to misspelled word variable, which is this they set for us. Beautiful. If not, return word. Okay, so pretty straightforward. Let's go ahead and put that down underneath our story words filter, but above the for each, because the for each is then establishing what the count is, and that's going to change based on what words we change. So I guess that would be the same for the beautiful one, but we're going to go ahead and keep it within this structure so that the for each activates at the end of all of our edits. So we're going to reassign the story words variable. Story words equals story words. Story words.map, we're creating a new array, and we're going to assign this parameter of word. We're going to give it a parameter of word. Arrow syntax and curly braces. This is then going to have a parenthesis at the end of it all, mapping it to be if the word is equal to unnecessary word, right? So return word that is not equal to, misspelled. Misspelled, and misspelled is often misspelled. Misspelled word. Because it has two S's instead of one. Misspelled word. Okay. Equals, or just that, yeah. Run it. Whoa! So it gave us a Boolean mob. And it showed us that there was one where it was equal to the misspelled word. But the way that this works is it's running through every word and then giving us a string at the end saying what that's equal to. So instead of equaling it to the Boolean value, we need to set this within a conditional, right? So the word is not equal to misspelled word, then you return the word. You don't return the Boolean value, you just return the word, and that way you get it to where the beautiful is deleted. We'll replace that in a second, but everything else is retained. Okay, so take a look at the story console to see. So if not, return word. So we did it in reverse. We basically said if it's not equal to that, return word, and then if it is, we'll need to put in another. I'm surprised I didn't have an issue with that, where it was like, there we go. We need to have this down here, just the curly brace like that, and then have an else statement. Else have it return the string of beautiful. Beautiful. There we go. Now beautiful. Now beautiful could be changed to anything, right? So beautiful could be magnificent or extravagant, and then that will change it there. Just an extra step. Okay, let's see. All right, so your great grandmother is going to read this story, and there is a bad word in it. Let's apply the .find index method to story words to find the bad word index. Start by declaring a variable called bad word index and setting it equal to the invocation of find index on the story words array. The find index callback function should check to see each word. If it equals the bad word variable that they gave us, which is freaking, declared on line 6, and return the index of the found word, then log bad word index to the console. All right, so we're going to check for this. We're going to still keep it above our for each method down there. So this will be bad word index. Bad word index is equal to, and we need to set this to a let, I guess. Yeah, that's fine. It could be constant because you're not changing this part. You would be changing the bad word and see if it's equal to that. But we'll just go ahead and use the let. Bad word index, this is going to be a for each method on the story words. Story words for each. For each, put in word that then checks. Let's do our greater than sign there, and block, code block. Set it equal to bad word. Each word. Yeah, so if it equals, so we need the return keyword here for the find index. So return if word is equal to bad word variable. And then you log bad word, or log bad word index to the console. And then with this, I bet we're going to replace that index. Undefined, what did I spell wrong? Let bad word index equals story words dot for each word, return word equals bad word. Story words. Declare a variable and setting it to the invocation of that on the story words array. Yeah, that's equal to the story words array for each. Word return I guess this would need to be a conditional, yeah. So if word equals bad word, set that in parentheses, do a code block here, return the word. It's still undefined. Okay, so we need to have it be an index of that, right? I thought it was where you could just do like the conditional statement and then it would show you. Oh, I'm editing I put in for each and not find index. Whoops. Find index. There we go. Hey, how's it going? Welcome. It's going pretty well. Figuring out some iterators, learning all sorts of methods that we can use on the functions within JavaScript. Okay, so now that should be 78 instead of undefined. Wonderful. All right, so the index of the bad word is 78. So now we can replace that. Access the element inside storywords array that has the index of bad word index using bracket notation. Set the accessed element equal to the more appropriate string, really. Save the code and check the bad word that has been replaced. Okay. Access the element inside the storywords array that has the index of that. Okay. So that can just be in one step, I believe, underneath. Let's separate this a little bit. Let's separate each of our methods we were testing out here, and keep our variables together. And then, yeah, separate this one more because we're going to add in the replacement. So I think you can just put in storywords, storywords brackets, and then 78. And that'll access the 78th index of the array, or yeah, 78th zero index, right? This set it equal to mutate the array to be really, the element to be really instead of freaking, and try that out. Okay, let's see if that worked. Surprising, where was it? It was like up in very tired, really long way. Yeah, it's right here. Okay, so really long way to go. Yeah, great. So that worked. So you can just access it like that. Very simply type in the story words, now that it's set to an array, the index that you're trying to change, and then change the element. Finally, let's simplify the words in the story to appeal to a broader audience. We can make sure every word in the story is 10 characters or less using the .every method. That method uses a callback function to test if every element in an array passes a specified condition. It returns true if all elements pass, and false if there's an element that does not pass. To start, define a variable called length check and set it to the invocation of the every method on story words. In the callback function, test whether every word has less than or equal to 10 characters. Log length check to the console to see the result. If true is logged, every word in the story has 10 characters or less. Otherwise, one or more words are longer than that. Okay, sweet. Let's do that. So we're going to say let length check equal, and this is going to be set to the story words dot every. This is set up to word. Same arrow notation. And from there, we want to check to see if, so do we start our conditional first or do we put that within another conditional? I think we just do return the value if it's true, or I guess don't do the return value yet because that will end the loop. We want to see if it is true, and then if it is, change it, but they don't do that in this step. So we'll go ahead and we'll put the return in for now. So return if word is less than or equal to 10 characters. And this has to be the dot length property of the word. Okay, so that doesn't show us anything, but if we console log that, then it will give us a Boolean value. So we then we do like a console log of that result. Console log that, and then it will show us true at the top there. Less than or equal to 10. Story words that every. It says it's true, but then the next step says that we have one word longer than 10. So let's see what we're missing here. Length check. Oh, we need to do this outside. I remember doing this before. So length check needs to go outside of the function. So console log length check. Because that way it's just like looking at an undefined value and saying whether it's true or not, and then it's like, yeah, sure, it's true, yeah. Or that it console logs something. It's like, yeah, it console logs something. That's truthy. Length check equals false. There we go. Okay, so now we know that one word in here is longer than 10. Yeah. Also, extravagant is, so I should probably change that back to whatever beautiful, so that we keep it to beautiful. Keep the next step, okay? Okay, so it looks like there's one word longer than 10 characters. Use an iterator method of your choice to access the word in the story words array that is greater than 10 characters, then manually replace the word in the original story string with a shorter word. Manually? Why are we doing that manually? Do a method. Do a method to do that, right? Do the, what did we do before? The index, find index method, right? It's probably actually, at this point, we know where it is and the story is short enough where we can replace that manually. But say you were like editing an entire novel and you needed to change a character's name, it'd be much easier to like find the indices of those and then change it, or do like Adobe, what is it, InDesign does, where you can just search the entire book and then change the one word. But anyway, okay, so we're going to do that manually here. So we need to access the word. So I think we just use find index again. I'm also thinking of using like index. Let's see. Yeah, just find index, I think. I don't know if we know any other ones yet. So let's find the index of that. So some ideas for replacement words that can be used are stunning, dazzling, or outrageous. Oh, this is breathtaking, right? Yeah, breathtaking. We already know what it is, but we're going to write the code for it to show our work. So console log the story words story words dot find index, and then this is going to have word equals a function, and then do the function of return word dot length is greater than 10. I don't know if that will actually work because it's just going to return. No, it did. Okay, so 111. 111 is where we have our breathtaking word. Okay. So that did work. So that works in one step. You can do it in two if you'd like. Just put like story words. Just, you know, use the method on the variable and then console log it. But here we just do it in one and it will still console log the result because we have that return keyword. So 111. We're going to go and change that. Oh, beautiful changed here again. Nice. But breathtaking. Let's see. Where was it? It was this one, right? Looking back at it manually. So, stunning, dazzling, or glorious. Yeah. Yeah, just like awesome. Awesome works. It was an awesome. Well, that doesn't work because it's you'd have to change the to an and. Let's just use stunning that they gave us. Stunning, 4,760 feet long. Okay. Patting yourself on the back. Great work. You've vastly improved the story using some of the most important iterator methods available to us to use as JavaScript developers. Feel free to continue using the iterator methods to make further edits, or click next to continue your learning journey. Congratulations, everyone, if you followed along. We have completed the iterator section on the CodeCademy JavaScript course. How satisfied are we? 5. No. Submit. Very happy. Thank you, CodeCademy. Exit survey. Alrighty, what is up next? The Q metric game. Okay. So we'll do this next time. And this is going to test our knowledge of all the iterators that we just practiced. We'll do this tomorrow or perhaps another day. But for today, I'll say so long. Thank you all for joining. If you tuned in, thank you for following along. Hopefully it was useful and helpful to help you start making your own little JavaScript browser games. So for now, have a good day wherever you are, and live long and prosper. See ya.